here and keep it right in this area right here. Okay. Okay, you got it going? Okay. So what we're going to talk about today is different wall parts. I gave you that information pack there, and then an assignment. On the front part of the page, let me grab one here. Talking about different wall parts, and that's what we're going to go over. So you have these different wall parts. The other page on the back of that, it has different petition backers or wall bucks, some people call them. And then the other page has some different types of corners. This is information for you to refer back to. But I'm going to go over them here one at a time. Let's see, where do I want to start here? Let's start with a trimmer stud. Okay, you have to visualize this as being big a wall. Okay, I guess the first thing I want to talk about, it's all made out of 2x material, and it doesn't matter if it's 2x4 or 2x6. What is it nailed with? 16Ds. So we always have to use them. I'm going to start with a trimmer stud, and if you find that on your sheet, it's the one running up an opening, whether it be a door or a window. And realistically, the trimmer stud is this one here. Imagine this as being full length. What the trimmer stud does, above a door or a window, there's weight bearing down from above, and you have to support that. And you support that by using trimmer studs and what's called a header. So this is a header, okay? Header sits on the trimmer stud, usually coming out flush here, okay? There are certain instances when it doesn't. Of course, the header width is determined by how much load is up there and how big a span it is across the opening. For those windows, if that was a wood wall, you could not use 2x4. I mean, it'd have to be 2x12 to support that. When you think about a house or a building that has interior walls, a lot of times the interior walls are 2x4. Okay, so trimmer stud supports the header, so of course it would have another one on this side, correct? Supporting this end, and that's the way they're framed. So like I said earlier, with that layout, they'd give you to the center of this opening, you would mark it, measure out halfway, and that's where these go. Nailing pattern. Remember, if you get right near your edges, you're going to split your wood. So generally you want to stay up an inch, inch and a half from your ends to nail, and the same way down. Okay, you can see that these are nailed on this side, but they're not on this side. Does anybody know the length of a 16D sinker? About like that. Yes, perfect. They're 3 1/4 or a little bit better. How wide is two of these 2x4s? 3 inches. So if I was to pound this nail right in straight, what would it do? It would come out the other side. And you don't want that to happen. And I'll tell you why. It's not so critical with the framing, but when the plumber comes in, the electrician comes in, and he's trying to pull wire or run pipe in a wall, and he runs his arm across that, what do you think's going to happen? It's going to, huh? It's going to cut him, and he's not going to be very happy. So how you get around that, it's not use a shorter nail. It's run them at an angle, and it don't take very much. You run that at an angle, and then it don't protrude out the back side. Now sometimes it will just a touch, but you try for that to not happen as much as possible. What's really critical with any framing parts is that you're nailing everything flush. You cut it to the correct length, and everything's flush. It's here, okay? We did practice some nailing earlier, just nailing 2x4s together, just a little bit of practice. I am going to get really picky with these, okay? So what happens if you powder your nail and this splits? What's that going to do? Okay, but it's still kind of holding together, but it gets a big crack here. What do you think that's going to do to the width?
It's going to widen it.
Yeah, so is it going to be right anymore? No. Okay, so you can't have that either. One thing I will tell you, and I think I talked about this before when we were nailing, because of the wood being dry in here, it's not stored outside where it keeps that 15% moisture, we get a lot of splits in here. So dulling the head of that nail really helps. So you just hit the head of it where what's going to drive into here with your hammer and flatten it off a little bit, and that does help with splits. But big thing is, don't get right up near your edges. So you can see this is nailed with 2 nails, okay? If this was a full length wall like it should be, you would nail, you know, 1.5 inches up from your bottom, then you nail that about every 16 inches up through there, okay? I think we kind of ran in this with something, I can't remember what we did nail together, but you nail, when we were doing with the sheeting, remember wood is not straight. So you don't nail here, then nail at your other end on a full length piece. You work your way right up the board from one end to the other, pulling the board around to get it straight before you nail. Because if this isn't lined up flush all the way here, it's making your wall thicker in spots, which is going to be a crooked wall, correct? Okay. And that really shows when you drywall, when you run trim especially. It makes it really hard on the trim guy. So you got to watch that. So we might as well move to the header next since we were working on the cripple. Header is 2x material nailed together, and you can see I have something inside there, okay? That makes up the correct thickness. Now, which way do you think them 2x4s are strong? Like this or like this for weight bearing down on them? Like this. A header does not go in there like this. 1.5 inches and 1.5 inches, that's not very strong. That would just bow down. And if you don't have the correct header, if you put them in there wrong, if that, say there was a header above that, that was a wood wall, if that bowed down, what do you think is going to happen to that window? It's going to bust the window. It's going to pinch it off where it won't open. It's not going to operate right. So the header has to be in there right to support the weight. Usually this in between here, you just use scraps of 7/16. We have all kinds of that out there. Of course, I don't want you cutting on one of our big sheets for a little dinky board. Now, if you look all the way around this, you can see that I did not take it right to the end, and I didn't take it right to the sides. You want to rip that stuff a little bit small. It doesn't have to be perfect. Usually a 1/2 inch in, 1/2 inch in, at least 1/4 in. Because the last thing you want is that sheeting sticking out. If that sheeting was sticking out up here and it stuck up a little bit, when you put your top plate on this, what do you think that's going to do? It's going to hold that top plate up, correct? So you're going to frame this. You get everything together, you drywall, then all of a sudden that OSB isn't going to hold that forever. That's going to go down. And then what do you think that's going to do to your drywall once that settles out? It's going to crack it out. So I don't know if any of you have any cracks in your house. Some of that stuff is caused by not good framing. Not that it can't still happen because lumber shrinks and twists, and that causes some of it too. But you want to not have that stuff happen as much as possible. Now, I see something wrong with this header. Do you guys see something wrong with this header? They did nail 2 nails at this end. There's always going to be 2 nails at each end. Of course, if this was a long header, same thing. You start at one end, you work your way down. It'd be double sets for this. Once you got to, like, if you were using a 2x12 header, you'd have to run sets of 4 down through there, about every 16 inches, and you work it down from one end to the other. But a header is required to be nailed on both sides. Okay, so they don't have any nails over here, but they did here. It's got to be nailed the same on both sides. So it would be 2 more nails here, 2 more nails here. Now this is not required to be nailed on both sides, a cripple, but a header is. Okay, so everybody has that. Let's see, what do I want to move on to? Might as well talk about some corners. So if you look at your page with corners, they have a couple different type there. They have, the bottom one shows an L corner, and the top one shows a triple corner. They're used in different situations. Triple corner is usually used in interior walls, especially outside corners. An L corner is used in exterior walls, and I'll explain why. Not that everybody does it this way, but it should be. And the whole purpose today is making things energy efficient. Austin, can you glance at this, make sure that's still right here, so this is going good. So if we have a wall, this would be your bottom plate, and your bottom plate for this wall, and it's making a corner, and this is the outside corner of a house, so outside's out here. This corner goes in here like this L corner. Oh, I'm sorry, no, don't. Right here, like this. On this wall that's running through, the L corner goes. When this wall gets stood, this wall would have to be built first because it's running on through. You stand this wall up after it's built, and then this wall would have a stud right here. Okay, this stud is fastened to this L corner, and that holds them walls together. Now, this is hollow back here. Why do you think you'd want to leave that hollow back there? What are we concerned with today? Energy efficiency. So what could you get back here? Insulation. And you want that. Wood is not that good an insulator. Okay, so if this was an outside corner and we used a triple corner like this, all that's back there, it would work the same. The whole purpose of that corner is so you have something to fasten this to, and you have nailer for your drywall. Okay, so it has that, but wood is not a good insulator, and on an exterior wall that would let a lot of cold in, all that wood and no insulation. Okay, where this you can get insulation in, but yet you still have your corner for nailer. You got drywall nailer here, drywall nailer here. Okay, does that make sense? So moving on from the corners, any questions with the corners? It's only 2 types. Oh, I want to kind of go to interior walls. So it's the same thing. If this was like a bathroom in here and you had an entrance to a bedroom here, and then this was a hallway, this triple corner works good out here because you have your nailers for drywall, and you got this good and solid out here for corner bead, and we'll get into that later. When you install corner bead for drywall, you need real good nailer there for that, for it to hold up good and for you to get it on good. So that's why these are used in interior. Of course, in interior, we're not worried about insulation as far as for heating purposes. Sound deadener, yes, sometimes people will put insulation in interior walls so you can't hear a lot of noise from room to room. But as far as using it for insulation value, you're not. So we kind of referred to this as the bottom plate. That's one name for it. If you look on your sheet, it's called something else. What else is it called? Sole plate. Okay, bottom plate, sole plate, it's the same thing. So we've talked about the header, we've talked about the trimmer stud. Of course, these would be regular studs. Anything that's a full-length stud is a regular stud. Looking at this window here, this bottom board that the window would sit on when you placed a window in, that's called the rough sill. And then below that is called cripple studs. Anything, the way I was taught, and anybody I've ever worked around, anything short of a full-length stud is a cripple stud. So what else on here could be considered a cripple stud? The boards above the header here, yes. What else? The trimmer studs. Normally, anybody I've ever worked around, most people call that a cripple also. It's actually trimmer stud, but I would accept cripple stud there too, because it is a cripple stud. Anything short of a full length stud is a cripple. Okay. Now I want to talk a little bit about, well, we can go up to the top there, and we have top plates. Okay. So you have a wall up here, length with studs in between, whatever's in there. Of course, this plate would be the same length as this plate. We kind of went over that with our layout, right? So your first plates, that's what you would lay out and nail together. Okay, so then, Austin, you bring me another one in? Yes, right here. So then this one would be with this one up here, and that would come together like that. Now, a couple different things with that double top plate, and you can see that on there. You have another plate that goes on top of this, okay? That's usually done later. So if this was your wall down here like this, and let's say this is your top plate, this is the single top plate, the first one that you nailed together. These are usually ran, you can see my seam is here. To tie this wall in good, when you double top plate, that goes and crisscrosses over that. That way, this is nailed up here, but also down here you can nail and tie that wall together real good with a 2x4. Okay, everything has to be cut right and put together right. Now, if you're looking at a wall and you left a gap here in that wall like that, would that wall be right if you had a gap here? No, it would start making something big. So when this stuff's nailed together, everything has to get drew tight. It's cut to the correct length and it's drew tight and everything's lined up. If you start leaving this top plate in like that, it's going to make that wall thicker at the top. So you got to force that wood to go straight. Okay, so that's double top plate. One reason for it is to tie the walls together. The other reason for it, when you're framing something, you want everything to stack. So your first is your floor joists, and you put them on 16 on center, say. Then your studs. So if this is a floor joist running right here, you want to start layout for your walls at the same end, and you want that stud right directly above that floor joist. When you get up here at the top after your double top plate, you want your rafters to fall right on those studs. There's a number of reasons for that. One is bearing, so it all bears down on each other. All the weight's transferred right down to the floor joist. Another reason for it, if you think about a plumbing or a heating guy that's trying to run ductwork or plumbing up a wall, if you have your floor joist and this floor joist is here, and here's your plate, and then you got this stud over here, he might have a hard time getting his material up through there if you don't have that stuff stacked right above each other. So you got to think about that when you're framing. Now, rafters, talking about a handmade, you cut them out of 2x10, 2x12 rafters for a roof. Them are on 16 on center. But we kind of talked about this the other day. Trusses are usually on 2-foot centers. Okay, so if your walls are on 16 center and your floor system's on 16 on center, and then you get to your roof and it's on 2-foot centers, and that's normal. Of course, them are not going to line up. The trusses are not going to line up, and that's part of the purpose of the double top plate, to help support that. So you got this double top plate here. So even though you're on 16 on center here, and then your 2-foot center for your trusses, that's going to fall in the middle of 2 studs, some of them. And that's the purpose of that double top plate, to help support that. If you only had a single there, that would belly down. Eventually, it would bow that board down, and then your roof would go like this, up and down, up and down. I'm sure, have any of you ever been up on a roof and looked and seen one that was crooked? It was because they didn't have these rules, and people didn't think about that stuff a long time ago. But today they do, and that's why there's certain codes. So the last thing I want to talk about is intersecting walls. So intersecting wall would be if you had a long wall here and then you had, say, where a dividing bedroom wall was, or whatever it may be, bathroom on this side, bedroom on this side, so you have a wall here. Intersecting wall is where that comes together and meets this wall, okay? So in framing, all your outside walls are built first, and then you move into interior. So you got to know where these are going. So this wall butts into this, and you have what's called a petition backer, goes right where that wall meets, and it's built up just like this, like a U. This does not always have to be right solid here. These have to be solid studs here. So they line up just like this. And that way, this wall is already built. When this wall, remember you're building your walls like this and then you stand them up. It's called platform framing. When this it has a stud right here in the corner, and that gives you a place to line this up, nail it. You have drywall nailer here, 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 and here. Okay, that's called a petition backer. Okay, does anybody have any questions with this? Okay, so your assignment, and like I said earlier, make sure you read all your directions. Okay, otherwise you miss things and then you lose simple points where you did everything right, but you didn't turn something in, or you didn't do this little thing just so you got all the points. The stuff that I want to use to build this stuff has to be built to certain lengths because it's practice cutting, and then I want you to make sure everything's lined up when you nail it. This, of course, is nailed with 16s through here, through that side, staying in that inch, inch and a half, so you don't split your wood. If this was long length, it's the same thing. You start at one end and work your way down it, pulling it straight. Okay, you won't have to worry about that too much with this practice stuff on that assignment. Wait just a second. There's one more thing I want to talk about. What the wood I want you using to build these parts, or the stuff that we use for our concrete forms that we washed off. Okay, I want to use all that stuff up. After this is done, that wood's going to be pretty much trash, but we got some uses out of it, and that's what I like to do in here so we don't have a lot of waste. Okay, yep, I think that's it.